students, welcome back to Physics with Safdar. Now you are watching Fbise Past Paper Solution series. Today we are going to solve class 9 paper 2017 Numericals problem from section B. So let's start the solution. This question is taken from section B and it is number 3. Find the acceleration from speed time graph shown in figure. You can see in the graph easily velocity is given in meter per second, and on the horizontal axis you have time in seconds. 2 points are there, point A and point B. At point A the time is 5 seconds and the speed is 2 meter per second. The time is 10 seconds and the speed is given 4 meter per second. The acceleration from speed time graph can be calculated as acceleration is equals to slope of AB from the graph. It is clear you have 2 points A and B, and slope you can write is equals to change in velocity divided by time interval. The change in velocity you can write final velocity minus initial velocity divided by time interval. So you can write t2 minus t1. Now we mark VF, VI, t2 and t1 from the graph. This is point A. The time t1 is equals to 5 seconds and initial velocity you can take here 2 meter per second. This is the second point, that is B. You can take time here t2, that is 10 seconds, and final velocity you can take here 4 meter per second. So we can write slope is equals to final velocity minus initial velocity, 4 minus 2 divided by t2 minus t1, 10 minus 5. 4 minus 2 gives 2 and 10 minus 5 we can write 5. 2 by 5 give us 0.4. So that is the slope we calculated here, and we have written in the beginning acceleration is equals to slope of line AB, and here the slope we calculated, that is 0.4. Because you calculated acceleration, that's why you will write your final answer with the proper unit, that is meter per second square. Now question number 4. The question is, a train slows down from 80 km per hour with a uniform retardation of 2 meter per second squared. How long will it take to attain a speed of 20 km per hour? Look at this diagram, it will help you to understand the problem. In the beginning, the train was moving 80 km per hour. Then it slows up to 20 km per hour. It is very clear the speed is going to slow. That's why you get the retardation minus 2 meter per second square. And here you need to calculate the time in that the speed change from 80 to 20 km per hour. Now you will write what are the information given and required. So initial velocity is given 80 km per hour and the final velocity is 20 km per hour. The retardation is 2 meter per second square. Retardation means negative acceleration. That's why you will write minus here. And you need to calculate the time. When you look at the data is given, it is very clear. Acceleration in the standard unit, meter per second squared, but initial and final velocities are in kilometer per hour. And the SI unit of velocity is meter per second. So in step 1, first you will change velocities kilometer per hour to meter per second. Look at this. Initial velocity, it is given 80 km per hour. To convert kilometer per hour to meter per second, the given number, that is 80, multiply with 1000 for kilometer to meter, then divided by 3600, that's are seconds in 1 hour. After the simplification, we get 22.2 meter per second. So that's the velocity in meter per second. So you can write like this: 80 km per hour is equal to 22.2 meter per second. Now convert final velocity from kilometer per hour to meter per second. The final velocity is given 20 km per hour. The same method we are going to use here. 20 multiplied by 1000 to convert kilometer to meter, divided by 3600 to convert hours to second. After the simplification, we get 5.6 meter per second. So you can write here 20 km per hour is equals to 5.6 meter per second. With the help of equations of motion, we can find the time period. The equation is, we are going to here, Vf is equals to Vi plus A times t. Because you need time interval, so you can make time as a subject. Vf minus Vi is equals to A times t. Now Vf minus Vi divided by A is equals to t. Now the equation is ready and you can substitute all the values we have. Time is equals to final velocity, that is 5.6, minus initial velocity 22.2, divided by retardation, that is minus 2. 5.6 minus 2.2 over minus 2, after simplification we get 8.2 second, and that is the final answer. Now the question number 5 from the section B. The question is, a cyclist of mass 40 kg exert a force of 200 Newton to move his bicycle with an acceleration of 3 meter per second squared. How much is the force of friction between the road and the tires? First write the information given and required. The mass is given, mass of the cyclist. The mass is given 40 kg. The force exerted by the cyclist is 200 Newton. We have applied force, that is 200 Newton. And the acceleration is given 3 meter per second square. So that's the acceleration we have, 3 meter per second square. There is a friction between the tire and the road you need to calculate that one. Now this diagram will help you to understand the situation. Let's suppose the cyclist at this position and his mass is given, that is 40 kilogram. He exerts a force 200 Newton. This is the forward force. Look at its direction. You can see the force of friction which is acting between the road and the tire. The direction of forces are opposite. That's why first you need to check what will be the net force in this question. The net force, you can write difference of these forces. Net force is equals to applied force minus force of friction. Because we need force of friction, then you should know about these two values. What is the applied force and net force? The applied force is given 200 Newton. The net force you can find as mass times acceleration. The mass is given 40 kilogram and acceleration is 3 meter per second square. After the multiplication we get 120 Newton. Now we can use equation number 1. The net force is 120. The applied force 200 Newton and minus force of friction. 120 minus 200, you can write like this. It gives minus 80, and this minus you can cancel with this one. So finally we get the force of friction is 80 Newton, and that's the final answer. Now question number 8 from section B. The question is, a force of 50 Newton is making an angle of 30 degree with x-axis. Find its perpendicular components. First write the information given and required. We have force 50 Newton, so you can write force F is equals to 50 Newton, and it's making 30 degree with the x-axis. Angle is given, theta is equals to 30 degree, and we need to calculate its perpendicular components. It means you can calculate horizontal component and vertical component. This diagram will help you to understand the situation. This is the forces given. This is the force vector, and it's making angle 30 degree with the horizontal. The perpendicular components are Fx and Fy. You know well how to calculate horizontal and vertical component. Fx is equals to F times cosine theta. Now you can substitute the values. Fx is equals to force, that is 50, and cos of 30 degree. First you will calculate the value of cosine 30 degree. 50 into 0.866. Multiply these numbers, then you get 43.3. Because you calculated force, so you will write unit Newton. For the vertical component, that is Fy, Fy you know well is equals to F sine theta. Now you can substitute the values. The force is 50 and sine 30. Fy is equals to 50 and sine 30 is equals to 0.5. Now multiply both numbers, then we get 25. Because we calculated force, so you can write Newton here. So these are the perpendicular component of the force. Now this question from section C, the question is, the acceleration due to gravity on the surface of moon is 1.62 meter per second squared. The radius of moon is 1740 kilometer. Find the mass of moon. First write information given and required. Radius of the moon is given, so you can write like this. Radius of moon is equals to 1740 kilometer. The value of gravitational field strength on moon is given 1.62 meter per second square. So you can write G at moon is given 1.62 meter per second squared. In this type of question, when you have dealing with the moon, earth and other planets, you need to write the capital G. That is called gravitational constant, and it has value 6.67 into 10 raised to the power minus 11 with unit Newton meter square per kilogram squared. And we want to calculate mass of the moon. So you can write mass of the moon. The mass of the moon you can calculate by using this equation. Mass of the moon is equals to radius of the moon squared multiply gravitational constant at the surface of moon divided by capital G. Look at the information given. Gravitational field strength is given SI unit. Capital G is also given in SI unit. But radius, that is a distance, in kilometer. So first you need to change this distance kilometer to meter. You know well how to convert kilometer to meter. If you want to make conversion unit kilometer to meter, first you will write the given number, that is 1740, then multiply by 1000. Then we get 174 and 0000. It's better to write in the power of 10. So you can write 1.74 into 10 raised to the power 6 meter. Now you can write this meter value in your information like this. Now the equation is ready. You can substitute all the values. Mass of moon is equal to radius of moon square, that is 1.74 into 10 raised to the power 6 squared multiply by gravitational field strength at moon surface, that is 1.62 divided by capital G, gravitational constant, 6.67 into 10 raised to the power minus 11. After the simplification we get 7.35 into 10 raised to the power 22. Because we calculated mass, so you will write here kilogram. And that is the final answer, mass of the moon. Thank you very much for watching the video. Follow the playlist of the channel. In that you can find all the lessons you need for your Fbise Physics grade 9. Keep watching Physics with Safdar for better results in exam. See you in the next lesson. Share this video, subscribe to channel, press the bell icon for the latest videos. Keep watching Physics with Safdar.